Okay, let's use this table to actually use real data to make a projection using our linear regression. So this says, as the table shows, projections indicate the percent of adults with diabetes could dramatically increase. So you'll notice that we have the years 2010, 15, 20, and then it goes over here 25, 30, 35, and then 40, 45, and 50. So those are the years, and we're going to put those in list 1, but not yet. And then our list 2 will be our percentages that go with our list. Okay, so first of all, find a linear model. That means we're going to use the method for linear regressions that fits the data. Now here's the key, with x equals 0 for the year 2000, and we're going to round to 3 decimals. So that means we're not going to put in 2010. We're going to think of x equals 0 as the year 2000. So instead of 2010, we're going to use the year or the number 10. So as we go through, I'm going to subtract 2000 from each of those numbers, and the numbers that I'll actually use for list 1 will be the numbers I have written down. Okay, so I need to go through this procedure. First of all, I'm going to make my scatter plot. So I will go in to Stat and Edit. Remember to clear your lists. You use your arrow and the clear and then enter. Arrows, clear, and enter. Okay, so for list 1, I'm going to put 10, 15, 20, 25, 30, 35, 40, 45, 50. So we're going to go by 5s. And it's always good to double check your numbers after you enter them in, just to make sure that you have them in correctly. So I'm going to take a moment and do that. Okay, and then I'm going to go over to my list 2 and type in each of my percentages. The first one is 15.2. The second one is 17.1, 21.5, 24.2, 26.9, 29.0, 31.3, 32.4, and 35.6. And again, I'm going to make an effort to make sure that all of my numbers are correct. Okay, so we've got our numbers in there. Now remember, we have to go to our y equals. Make sure that our plot 1 is highlighted. Well, it's already highlighted because we just did an example, and clear out the equation. Now I'm going to calculate the regression. So let's see what it looks like. Press zoom 9. And it looks almost like a straight line, but not exactly like a straight line. So let's find the equation of best fit, the equation that would be closest to all of those points. Stat, right arrow to calculate, and number 4. Go down to store and press vars. Go over to y vars with your right arrow and press enter, enter. And then we can go down to calculate. So our equation is y equals a, and it says round to 3 decimals, 0.506x plus b, 10.721. That is the equation of best fit. Now, is that a good equation? And we see, yes, that's a good fit because R is 0.9926, very, very close to 1. So there's our equation. Now, let's use the model to predict the percent of adults with diabetes in 2031. Well, you can do this with your calculator if you want to graph it, or you could just substitute in a value into your equation and do it that way. Let's just substitute in. In 2031, what is x? Well, x equals 0 was year 2000, so x would be 31. So what do we get here? Let's go into the regular calculation mode and do 0.506 times 31 plus 10.721. And it says round to the nearest tenth, so 26.4, and this is predicting the percent of adults with diabetes. Now, let's go in and let's see if we can figure out that answer without doing the actual calculation. Let's go to the graph. So graph your equation and see how the line goes close to all of those points. Okay. Go to your y equals and turn off plot 1. So just go up to it, highlight it, and press enter. And then go back to your graph. If x is 31, we can do trace 31, and we get for y 26.4. Now here's our next one. In what year will the percent be 27.48? Well, in this case, 27.48 is our y. So we will solve that equation. I will subtract 27.48 minus 10.721, and we get 16.759 equals 0.506x, and now divide by 0.506, and we get x equals 33. So if x is 33, that means the year would be 2033. Now sometimes your calculator will round up to the next year my math lab will round up to the next year. So if 2033 does not work, type in 2034 and it's rounding up. Now let's go back to our graph or our equation, and let's put 27.48 in for y2 and graph. Let's see what happens when we find the intersection of those two lines. Remember, to find the intersection, I press second, calc, and intersect, and then press enter, enter, enter. And you should see that 33.09, which is about what we got here, would give us the same year for x.